Hi, let's talk about reflection. The rule about light is that it travels the shortest possible path. So if we want to find the path that light would take from point A to point B here, it would be a straight line connecting the two, right? So just from point A to point B, boom. But if instead we want to go from A to the mirror to B, our paths look different. It could be like this, going straight from A to the mirror, but then that leaves a longer path from the mirror to point B, right? So if it instead went at some sort of angle, that's a shorter path for point B, but if it goes straight down, it's a longer path. The best option is actually a straight line between A and a point called B prime, which is an equal distance behind the mirror to our regular point B. So before we look at our paths, let's just look. B prime is behind the mirror, equal distance that B is in front of the mirror, because B prime is actually the reflection of B. So the shortest path that includes the mirror is if the light goes from point A toward that B prime, but that's where it strikes the mirror. And then that bounces to the actual point B. Um, because yeah, light doesn't actually travel from point A to point B prime. Instead, it reflects once it strikes the mirror. We can see different examples of this when A and B are in different positions. So here they're closer together, and the shortest path for the light is still striking the mirror along the path of light from A to B prime, and then reflecting up to B. Same thing here and here. Doesn't matter their orientation, that is still the most direct path for the light. The objects we see in a plain, flat mirror appear to be behind the mirror, the same distance the object is in front of the mirror. So here's our mirror in the middle. Our object is the candle. Our image is this dotted line version of the candle. And the image that is created appears as if this version of the candle is just that same distance behind the mirror that the object is in front of the mirror. The law of reflection tells us that the angle of incidence equals the angle of reflection. Sorry, that's supposed to say reflection. Angle of incidence, if you remember from the bending light investigation, is the angle in which the light strikes whatever the material is. And then reflection is going to be just on the other side, but these angles should be the same size. Um, yeah. How do we figure out what can be seen in the mirror? Let's take a look at these shapes here with this mirror in the middle, right? We're going to pretend that these shapes have eyes and can see things. So the very first thing is knowing that when we look at a mirror, what we see appears to be behind the mirror. We know it isn't, but that's what it looks like. So when we're trying to figure out what can be seen in the mirror, we need to put those reflections where they will seem to be. So the first step is to project the object of interest to where it appears behind the mirror. Um, and then the next thing to consider, which, oh, sorry, let's clarify. The dashed ones, those are, our projections. This is, if you're looking in the mirror and you can see these objects, this is where it looks like they are. Okay. But how do you know though, still, if you can see something in the mirror? So you can see something in the mirror if you draw a line connecting you to that projected object, and it intersects, that line intersects with the mirror, right? So we'll try this with each shape. Let's start with the circle. So we're starting with the circle, and these are the objects we're going to be seeing if we can see in the mirror. Sorry, that square shifted a little, I think. So first of all, a line from the circle to where its reflection would be. It does not cross the mirror. Remember, this line is the mirror. So the circle cannot see itself in the mirror. Then we do a straight line from the circle to the square, and that crosses the mirror. So the circle can see the square in the mirror. And finally, the triangle, and again, it crosses with the mirror, so the circle can also see the triangle in the mirror. It just can't see itself. Let's look at the square now. So the square can see the circle because a straight line intersects with the mirror, can see itself too, and it can see the triangle. So the square can see everyone in the mirror. And finally, the triangle, it can see the circle, can see the square, but it can't see itself in the mirror. So again, you can see something in the mirror if a straight line between you and the projected object, as in where the object appears like it is behind the mirror, if a line between you and that object passes through the mirror. So to wrap this up, I want to talk about this example you might have seen online. I do think I saw like one or two of these again recently, but it was bigger a while ago. So let me describe the situation. So we have a person standing in their bathroom holding a towel up to their mirror. Okay, so the towel is between them and the surface of the mirror. And then they have someone over to the side recording the situation with a camera, with their phone, which is why we see it online. So we want to know, because what the phenomenon is that people say is, oh my goodness, look, how does the mirror know what I'm doing behind the towel? But we just learned how you know if something can be seen in the mirror, right? So obviously for the person behind the towel, they can't see themselves. They can't see the mirror. Maybe from the side they can, but they can't where the towel is. Obviously, it's blocked. But the person with the phone is off to the side. So let's see what they, and therefore the phone, can see. So we just need a line connecting them to where the person appears to be in the mirror. And would you look at that? They can see the reflection of the person because it doesn't have to do with what is in between you and the mirror, but instead where someone is looking to whether or not you're appearing in the mirror. So, and this is because mirrors aren't magic. They just reflect a bunch of light. So like the person is hiding from this portion of the mirror. There's all this part of the mirror too that is getting light from them and producing a reflection. A reflection that is believed to not be possible, but really is entirely possible, especially because the person seeing that reflection and recording it has an unobstructed view of the reflection, unlike the person holding up the towel. So anyway, next time you see that video or somebody's talking about it, you hopefully can explain that that is not how reflection works. And this is why. That's all I've got for you. Have a good day.